Okay, in this video we are going to take a look at intercept form. So intercept form is when we have these two sets of parentheses, two binomials being multiplied. So the first step for graphing this will be to identify my A, P, and Q. So here my A will equal -1/2. Okay, so remember this number in front, since it's not in the parentheses with the x's, the sign does not change. So this is just -1/2 stays the same. For our p value, that's going to be the opposite. So here I have +7, so p will be -7. Here I have -2, so q will be +2. Right, so this is intercept form, so it's very easy to find what my x-intercepts will be, and they will be at -7, 0. Write this out, x-intercepts, so we have -7, 0, and 2, 0. Okay, so I'm going to go ahead and graph those 2 points. So I have 2, 0, 1, 2, and -7, 0. So 1, 2, 3, 4, 5, 6, 7. After that, we are going to find our axis of symmetry, so that halfway point between these 2 points. So I'll first see if I could do it by looking at the graph. So starting with these 2 points on the outside, go in 1, 2, 3, 4, and it's going to be right in between these 2 lines. So just to double check what that value will be, I'm going to use that formula, the x equals p plus q divided by 2. So just thinking about finding halfway between any 2 points, you would divide it, the sum of those 2 points divided by 2. So my p value is -7. My q value is 2, so plus 2 divided by 2. -7 plus 2 is -5 divided by 2, and we have -2.5. Right, so that's my AOS. I'm going to draw that in. So this is -2.5. I go in 1, 2, and a half. So remember, this is not a point. This is a line for this part. So our axis of symmetry is going to go right halfway between these 2 points and down. Great. So since we found our x value, our axis of symmetry, that x value is the same as the x in our vertex form, in our vertex. So I'm going to plug this value back into my original equation. So I'll have y equals -1/2, and then x will be -2.5 plus 7 times -2.5 minus 2. Okay, so -2.5 plus 7 will give us 4.5. So I'll have y equals, and then I'm just going to bring what's on the outside down, so this will be -1/2. And then just adding what's in my parentheses, so this comes out to be 4.5. And then -2.5 minus 2 would be -4.5. Okay, and then multiply that out. So I'm just going to calculate that. We have -0.5 times 4.5, 4.5, and then times -4.5, and that gives me 10.125. Okay, so here my y equals 10.125. So these two negatives cancel out to give us this positive value. So my vertex is going to be -2.5, which is our axis of symmetry. And then after plugging that into our original equation, we found the y value is 10.125. Okay, and then just graphing that. So this is our negative 2.5, and then go up 10.125. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then just a little bit above 10 for 1.25. And now we can graph our parabola. So, and then labeling our points. So over here I have 2, 0. This side I have negative 7, 0. My vertex is negative 2.5, 10.125. And my AOS is x equals, what was it, negative 2.5. Okay, and now we want to double check what we have by typing into Desmos our original equation, so it's negative 0.5, and then we have x plus 7 and x minus 2. Okay, and I can just click on my vertex, negative 2.5, 10.25. I have the same thing, and then the x-intercepts negative 7, 0, negative 7, 0, 2, 0, and that's the same. It looks similar, right? Maybe that one looks nicer. Okay, so that's our intercept form. So let's have one last question with critical thinking. Okay, so if we were to try to figure out what the equation of a parabola would be for it to cross through this point, so this point is negative 1, 0, and this point we have 1, 2, 3, 4, 5, 5, 0. So how would we figure out what the equation of that parabola would be? So think about your intercept form and kind of work backwards. Okay, so thinking about intercept form, working backwards, we have negative 1. So we know that our x-intercepts are p0, q0. So if my p-value is negative 1, then we flip the sign to get it back into the equation. So let me just write out the formula here, x minus p, x minus q. Okay, so if our p0, q0, so my p0 is negative 1, 0, and my q0 is 5, 0. So to figure out, so that means my p is equal to 1, or negative 1, and my q is equal to 5. So now we need to change those signs, because remember, to take it out of the formula, we flip the sign. So we would flip it again to put it back into the formula. So I'll have y equals, the a value we don't really know, and remember that tells us how, if our parabola is flipping downwards or upwards. But the basic question is, we just want a parabola that goes through these 2 points. So I'm just going to leave a as 1 for this example. And we'll have x, and it's minus 1 here, so it'll become plus 1 coming back into the equation. And then x, it's positive 5 here, so it would be minus 5 back into the equation. Okay, and let's take a look. What would that graph look like? So we have x plus 1, x minus 5. So typing that in, oops, x plus 1, and then x minus 5. Okay, so we have a happy positive parabola. And if we click on those 2 points, it does successfully go through negative 1 and positive 5. So that's how we can graph that equation. And if we wanted to flip it around, remember you just put that negative sign, and that flips it into a frown. Okay, so one last question. If we have this for our equation, what would it look like in standard form? Okay, so this step's pretty easy. We just do FOIL or the box method, whatever works for you. So we'll have y equals, we have x squared minus 5x plus x minus 5. Okay, so our standard form will be y equals x squared minus 4x, so combining your like terms, minus 5. And this is our intercept form.